Alrighty. I got a little bit of stuff to hand back today, not much, but some. We'll get to that later. I want to stamp quiz tomorrow, but let's get started with the retrieval. So before we start said retrieval, let's get the equation of that given line first. Okay. So what do we think the slope of that line is? Negative 1/4. Everybody agree with negative 1/4? What's the y-intercept of that line? 4. So what would the equation of that line be? Y equals negative 1/4 x plus 4, I think is what I heard. Yep. Okay. All right. So that's the equation of that line. I want you to graph me a line parallel to it and a line perpendicular to it. Okay. Give me the equations in y equals mx plus b form. Then in number 2, we're going to reflect that one over that line. So we're going to have to graph that line first. So just do those two. We'll do the jump start together. Okay? So just do those two right now. Go. So for a parallel, so the equation of your parallel line should be y equals negative 1/4 x plus something. And that something can be whatever it is you want it to be. Right? But anything but 4. Yep, exactly. Okay? Your equation of the perpendicular line should be y equals 4x plus something. Okay? And that something can be, again, whatever you want it to be. This time, including 4. Okay? With me on those two. Okay? So first, we've got to graph the line negative 2x plus 4. 1, 2, 3, and 4. 2, 1, 2, 2, 2, 2. Okay. So there is that one. So if I reflect, I got to reflect perpendicular. So this has a slope of negative 2, which means then that my perpendicular slope would be positive 1/2. So if I go down 1 and left 2, that means I would go down 1 and left 2. So right there would be A prime. Down 1, left 2, down 1, left 2, down 1, left 2 puts me to the line. So that was 1, 2, 3 of them. 1, 2, 3 of them puts me to C prime. Now B is kind of goofy. Okay, so right there, and then it actually ends up being, I believe, at the origin. I should have just given you B prime because I knew B prime was going to be the goofy one. Okay? And then we can draw in our good. Yeah. So Randy has decided to study the triangle that's graphed right there, RND. Okay? Consider all the special properties that this triangle can have. So what are some of the properties that a triangle can have? What are some of the special names for a triangle? Isosceles. What's an isosceles triangle? Two equal sides. Love it. Let's do it.
Right triangle.
A right triangle. What does a right triangle have?
Has
It has a right angle. Yep.
equilateral.
What's an equilateral triangle?
All of the angles are the same.
That would be an equiangular triangle, but an equiangular triangle is also an equilateral triangle. So what would be an equilateral triangle?
They all add up.
Nope, every triangle has that. You said you gave me all three angles are the same. And I said that's equiangular, not equilateral. Lateral. What's the only other part of triangle? What's the only other part of triangle? Angles and sides. So we have three equal sides. Yep, the equilateral triangle has three equal sides. Equiangular has three equal angles. Those are both the same. Equilateral and equiangular. Okay, what's an acute triangle? There are acute triangles out there, yes. Anybody know what an acute triangle is? All three acute angles, so all angles are less than 90 degrees. Some more yet? What's a scaling triangle? No equal sides, yep. Okay, so in terms of side lengths, we've got scalene for none, isosceles for two that are the same, and equilateral for three that are the same. In terms of angles, we've got an acute triangle, which has three acute angles. We've got a right triangle, which has one right angle. There's one more. There's an obtuse triangle that has one obtuse angle. Yeah. Okay. All right. So we got all those, right? All right. So let's figure out now. So look, just by pure looks alone, okay, what do we think triangle RND is? Just based on first glance at it. You think it's a right triangle? But it kind of looks that way, right? So, okay, so we're thinking it's a right triangle, okay? You think it's isosceles too? Does RD kind of look like same as DN? Okay, this is purely a guess, so we can't be wrong on this one, right? So do we agree that this looks like an isosceles right triangle? Yeah? Okay. Right, so our guess is that this is an isosceles right triangle. So if that's the case, then two sides have to be the same, and we have to have a right angle, right? How are we going to find that we have a right angle? How do we know if an angle is right?
You could find the two slopes as lines, and if they're
That's the only way we have right now, right? Yep. The only way we have right now is if the slope, those two line segments are perpendicular. So we got to find the slopes. Okay. So what you need to do now, and I'll give you a couple minutes to do this, you need to find me three slopes and three side lengths. Okay? Got it? Go. Two, three, four, five, six. One, two, three, four, five, six, seven, eight. 1, 2, 3, 4. 64, 80, that's what I got for them. Yes? Yeah. So did we confirm that we have a isosceles right triangle? Okay, why? Okay, RD is congruent to DN. So this side right here is congruent to that side right there. That would be the isosceles part. Okay. And how do we know that they're perpendicular? Opposite, is that what you're saying? Yep. They have opposite reciprocal slopes. Yep. So that makes this be a right angle in there. And so yes, we have that. Now, if this were a quiz question tomorrow, you would have to show all of this in order to say this. Okay? You would have to show me that the lengths are the same to make it the isosceles. You would have to show me that the slopes are opposite reciprocals to make them be perpendicular. Okay? All right? Tomorrow's all about math. It's not about visual. Okay? So, you just got a job at the quadrilaterals division of your uncle's shape factory. In the old days, customers called you up with and described their quadrilaterals they wanted over the phone. Like, I'd like a parallelogram with this. Okay? But nowadays, customers using computers have been emailing orders in lots of different ways. Your uncle needs your team to help analyze his most recent orders listed below. Identify the quadrilaterals and help the shape makers know what to produce. Okay? So, here is an order. We need to first graph those 4 lines. Yes? Okay? So let's talk this one first. Let's go with the blue one here first. Okay? What can you tell me about the blue line? The y-intercept is 3. 1, 2, and 3, so I would put a dot right there. Yes?
The slope will be going down to the right.
So down how many and to the right how many?
It'll be going down 3 to the right.
Down 3 and to the right 2, so it would be going through right about there. Okay? All right, so we could draw in that line. Yes? Then we need this line. What can you tell me about the green line now? Okay. Y-intercept is -3. And so that means what? Up 3, I don't know, over. To the right 2. Yep, exactly. Up 3 and to the right 2. Up 3 and to the right 2. Up 3 and to the right 2. So then that one would look like that. Yes? Okay? So we have an intersection point right now. Yes? Let's label that intersection point. Let's label that one to be point A, because it's the first one that we have. We agree with that? Okay. Now we can go to the next one. What can you tell me about that? What can you tell me about the red one? Y-intercept is 9, which is actually at the top right here. Okay, and? Okay, so give me 2 directions and 2 numbers. Yep, down 3 and right 2. Created another intersection point, yes? So let's label that one B. Okay. And lastly, what can you tell me about the black line? Y-intercept is 3. Up 3 and to the right 2. I'm going to put this one here as C, this one here as D. With me? Okay. So now we need to know the slopes of line AB. So that is my green slope. What is the green slope? 3/2. BC, that is the red slope. -3/2. CD, that is the black slope. 3/2. And AD is the blue slope. Okay. Are some of these lines or sides parallel, perpendicular, or neither? Which ones are parallel? Because they have the same slopes. Are they perpendicular? Why not do it?
Oh, because it's not like split.
Exactly. They're opposites, right? If I work left to right on those 4, they're opposite, but they're not reciprocal. So in order to be perpendicular, they have to be both opposite and reciprocal. So just 2 sets of parallel sides. Okay? So what potentially do we have now? What shape?
Square. Or
It can't be a square because they're not perpendicular, it would have to be perpendicular in order for it to be a square. So no on the square. Parallelogram, right? It's all we got. Only potential. But what's got to be true in order for it to be a parallelogram? We already showed that the opposite sides are parallel. Now we got to show that the opposite sides are congruent, equal in length, right? Okay? So find me the lengths of those 4 sides. Go. So 3 squared is 9, 2 squared is 4. So it's square root of 13. So all of them are the square root of 13? So they're all equal, right? Okay? So are we still on parallelogram?
We're on a rhombus.
No, now we're a rhombus, right? Because all 4 sides are equal. Okay? So it bumped up from a parallelogram to a rhombus. Could it be anything more? No, because the sides aren't perpendicular. Because the sides aren't perpendicular. Yep, exactly. So it's just a rhombus. But then it asks, is there anything special about the diagonals? So let me put in here the diagonals now of this figure. What is so the diagonals are those pink lines. What's the slope of DB? 0. What's the slope of AC? Undefined. Are those perpendicular? Yes. So those are perpendicular. Okay. Rhombus have perpendicular slopes too? On the back of our sheet? Yes or no? Should be a property of a rhombus, yes? Diagonals are perpendicular? Yep. Yep. All right? Love it. All right. What I want you to do right now is I want you to do letter B on the next page. This one's a little bit easier because it's just giving you the points, where the points are. Okay? Do letter B. Find me what figure it is. Yeah, I totally forgot to record this. But so anyways, there's everything for that one, for the trapezoid. You guys missed out on me saying a trapezoid. Okay? All right. Let's do, let's do C together. Quadrilateral with vertices at these points. W is at 0, 5. That's here. X is at 2, 7. Y is at 5, 7. And Z is at 5, 1. Okay, make sure, yeah, 0, 5, 2, 7, 5, 7, 5, 1. This is a goofy one. I'm with you. Yeah, he's right. Yeah, yeah.
It looks like it should be something.
It looks like it. Slope of xy. 0. Slope of yz. Okay. Slope of yz. Undefined? Yep, undefined. So right off the start, what can you tell me about those two?
They're perpendicular.
They're perpendicular. Yep, exactly. So we can jump right down here to say that this one, YZ, is perpendicular to XY. Okay? Slope of ZW. One, 2, 3, 4. 1, 2, 3, 4, 5. Yep, I go -4/5. And slope of WX. 1. Anything else? Parallel, perpendicular. Nope, just those two. Okay. Side lengths. XY. 3. YZ. 6. ZW. Square root of 41? Nope. Wx. It is 2 square roots of 2, yeah, because it's a square root of 8. Any of those equal congruent? No? Okay. So what is the shape then? It's just a quadrilateral. Yep, that's all it is. It's got no special name. Love it. Okay. Let's go over your homework. Let's see what we got going on tonight in our homework before we check the last couple of nights' homeworks. So this is 8-3 here now. Not 8, there we go, 8-3. All right. So page 1 of your homework is solve for those particular variables. So it's just get that variable equal to itself. Or you need to get that alone on one side. So for instance, it says in number 1, solve for h. So I'm going to divide this side by pi r squared. If I do that to that side, I got to do it to the other side. Dividing by pi cancels that out. Dividing by r squared cancels that out. So h here is equal to capital V divided by pi r squared. Okay. I've done them already. It shouldn't take you more than 2 steps to do all of those. Okay? Maybe 3. Okay? Alright, next page then has, here is a quadrilateral. You tell me the best name for it. So what do you have to do? Slopes and side lengths for all sides. Okay? You don't just get to go off of a visual of it looks like it's this. Okay? You have to prove that it is whatever you think it is. Okay? Same with number 8. Okay? Tell me what that is. Slopes and sides. So I need to see 4 slopes, 4 sides for both of those. Okay? Same in number 9, but here now you've got to plot the 4 points first. But then again, 4 slopes, 4 sides. Okay? On the next page, apparently the numbering was wrong, but that's okay. It happens. You probably wouldn't have even noticed it had it not been up here. But on this one, you're giving me the equation for all of these lines in y equals mx plus b form. Okay? All right? Any questions on the homework? Any reason that it can't be done by tomorrow? Nope. Plus, get 10 minutes to work on it in class.